For our second example of section 7.2, this is going to be the case that produces two triangles. Okay, and sometimes you can tell going in, there are a lot of rules I could ask you to memorize, but the best thing, honestly, that you can do here is just start working it out, and then you'll realize whether it's going to work or not. Because to me, it's worth just working through it rather than just memorizing different ways of telling before you start. So in this case, we have a triangle ABC where capital A is 55.3 degrees, side little a is 22.8 feet, and side little b is 24.9 feet. So let's draw that. We have A to B, and then C is up there somewhere. We'll just put it right there for now. Okay. Here's what we know. We know this angle. We know the side opposite of that angle. And we know that little b is 24.9. Okay. Is this the ambiguous case or not? Look at it. What do we know? Two sides. That's the one we have to be careful of when we know two sides. Where's the angle? Not in between them. That's the bad case. Okay, so that means there's a possibility that there could be no solution, so the triangle does not exist, or there will only be one triangle that works, or that there will be actually two completely different triangles that work. So let's start working it out and see how to figure it out. What is going to be the first thing that I can find using the law of sines?
That little a over sine of a is equal to 22.8 over big sine of b.
Does that make sense, guys? What of the three things, what is the one I can find right now?
The angle of B.
Angle B. Okay, let's start there. We know that 24.9 divided by the sine of B must always equal any other side, and the only other one I know is 22.8, divided by the sine of its opposite angle, which is 55.3. To use law of sines, you have to know a pair of opposites. Okay? Now we cross multiply, and we're going to solve for the sine of B. Not B, we're going to solve for sine of B. So we know that the sine of capital B is going to equal 24.9 times sine of 55.3 divided by 22.8. Do you guys understand that? Hang on, I'll show you that. We'll go one more step. We know that 22.8 times the sine of B must equal 24.9 times the sine of 55.3. Okay. Now we're going to solve that for sine of B, and then we're going to stop there and have a chat. Can you guys tell me what sine of B has to be?
0.897. 8, 6, 7, 8, 3, 4, 3.
Okay. That's what sine of B has to be. Is that possible?
Yes.
So I expect to get an answer from it. Make sense? Okay. Use the inverse on that, and so second sign it and tell me what angle B is according to your calculator.
63.87.
63.87.
920,366.
Okay. So we think that B is around 63.87920,366 degrees. And so for this problem, we only need three significant digits. So we would say that that's about 63.9 degrees. Okay, that's what we think little b is. And we got that by inversing 0.8978678,343. In which two quadrants can the sine value be positive?
First two.
The first two. So that means that that answer could occur once in the first quadrant and once in the second quadrant. Do you guys understand that? That's the problem with law of sines. That's where the ambiguity, we start to run into it. When you use law of sines to solve for an angle, there is a possibility that that angle could be from quadrant 1, which is what your calculator will give you. But there's also a possibility that that could happen in quadrant 2. And because a triangle can have an angle in it that is obtuse, that is greater than 90 but less than 180, then we have to consider that possibility as well, even though our calculator only gives us the first quadrant possibility. So this is our quadrant 1 possibility. You have to know to come off to the side and say there is a possibility that B could equal the quadrant 2 angle. And how would I find that quadrant 2 angle? 180 minus that reference angle. So 180 minus 63.9, which would mean in that case B is 100 and, guys, is it 116.1? 116.1? Yes? 116.1. Okay. That is your second possibility. That is your quadrant 2 possibility. And that produces a whole separate scenario. So that means we have to work both of those problems completely. Okay. So what your book does is they call this B1 and they call this B2 so that we can keep them separate later. So we're gonna have to work it, 2 separate ways, and we'll have 2 separate triangle possibilities. Okay, let's go back to the first case, the quadrant 1 case. If that angle is acute, that leaves me with angle C missing. Well, capital C, and we'll call it C sub 1 as well, would have to equal 180 minus B1 minus the given A. So if that's the case, then capital C equals what? Let's pause and make sure everybody understands. Okay, so if little b, capital B is 63.9 and capital C is 180 minus that minus the one we were given, and we got 60.8 degrees for that. On this triangle, what is the only missing value now?
Side C.
Little c. And we can always find side little c by taking c over the sine of big C and setting it equal to A over the sine of capital A. Then we can cross multiply and solve for little c. And because we're not looking for an angle, we won't have to use the inverse here. So we know that side little c. Okay, so c times sine of 55.3 must equal 22.8 times sine of 60.8. That means that little c is approximately what? 24.2. So 3 sig figs will give us 24.2 feet. All right. And that your book calls that C sub 1. Okay, does everybody understand that? Any questions about how I found those missing things over there? Okay, for the second possibility over here, we will do exactly the same thing, but using this as capital B instead. Okay? So now we'll find capital C again by doing 180 minus the second B minus the given A. And that will tell us what the other possibility for capital C is. What is it? 8.6 degrees? Yeah? Okay. All right. And remember we talked about with sig figs that for the angles, we're just going to round them to the same decimal place so that they will add exactly to 180. And that's pretty much what your book does. Depending on your science class, you'll have to figure out, how your instructor wants you to handle that. Okay, that's how we found capital C2. And then we're going to find little c2 again. C2 over sine of capital C has to equal little a over sine of capital A. We'll cross multiply. and solve for little c. So as you guys can see, like, the only bad thing is it's just tedious because you have to work everything twice. So what is little c in this case? 4 point what?
1.5.
So 4.15 feet. And that's the worst case. When you're given the ambiguous case and it turns out that both sides work completely out. Any questions about that? How many different triangles did we get? Two. One was acute, one was obtuse.
And
Makes
so
sense.
if only one of them can work, whenever we write one, or like we would write the answer.
Well, you would write does not exist on one side, and you wouldn't have to write answers for that one. We're going to see that in a second.